Understanding and addressing ground current problems along with uninterruptible power supply or UPS transfer issues requires a systematic approach. Ground current, as you correctly identified, often arises from improper neutral ground bonding. The presence of 16.5 amps on the ground at the main neutral ground bond indicates a significant issue needing immediate attention. Elevated ground current poses several risks, including equipment damage and potential shock hazards. The core principle to remember is that neutral and ground should only be bonded at the main service entrance panel and at separately derived sources such as generators or transformers. Bonding them elsewhere creates a path for neutral current to flow in the ground conductor, leading to the problems you observed. To rectify the ground current issue, firstly, conduct a thorough inspection of the entire electrical system to identify and disconnect any unauthorized neutral ground bonds. This involves meticulously tracing the wiring and connections throughout the facility. Secondly, verify that the neutral and ground are bonded exclusively at the main service entrance panel and at any separately derived sources, ensuring compliance with electrical codes and best practices. Thirdly, after making the necessary corrections, utilize a ground current tester to verify the effectiveness of the measures taken. Monitor the ground current at various points in the system to confirm that it has been reduced to acceptable levels. Turning to the UPS issue, while the theory of motors backfeeding power to the UPS input holds some validity, it's crucial to avoid jumping to conclusions without a comprehensive assessment. The assertion that backfeeding motors are solely responsible for the UPS transfer failure warrants further investigation. Installing an isolation transformer might offer some benefits, but it may not fully address the underlying problem if other factors are at play. Therefore, firstly, thoroughly inspect the UPS wiring and connections for any loose, damaged, or corroded components. Ensure that all connections are secure and properly torqued. Secondly, rigorously test the UPS battery and charger to verify that they are functioning optimally. Check the battery voltage, capacity, and charging rate to ensure they meet the manufacturer's specifications. Thirdly, carefully evaluate the load connected to the UPS and identify any potential sources of backfeed power, such as large motors or variable frequency drives. Analyze their characteristics and potential impact on the UPS operation. Fourthly, consider a UPS upgrade or the implementation of additional filtering measures if necessary. Explore options such as harmonic filters or surge suppressors to mitigate any adverse effects from the load. Fifthly, collaborate closely with the UPS manufacturer to thoroughly troubleshoot the issue and determine the most appropriate solution. Leverage their expertise and technical support to diagnose the problem accurately. Regarding the actions, it is essential to gather and analyze all pertinent data before making any recommendations. This involves obtaining detailed measurements of voltage, current, and power quality at various points in the electrical system. Collaboration with qualified electricians, engineers, and the UPS manufacturer can provide valuable insights and ensure a well-informed decision-making process. Remember that all electrical work should be performed by qualified personnel and in strict accordance with applicable codes and standards. Safety must always be the top priority. Understanding the potential for motors to backfeed power is important. When utility power is lost, motors with significant inertia can continue to spin, acting as generators and feeding power back into the electrical system. This backfeed power can interfere with the UPS ability to transfer seamlessly to battery power, leading to malfunction. The amount of backfeed depends on the size and type of motor, its load, and the efficiency of the motor and driven equipment. Larger motors driving heavy loads will produce more backfeed. In call center environments with numerous air conditioning units, the cumulative effect of these motors backfeeding can be substantial. Variable frequency drives controlling these motors can also contribute to backfeed, especially if they are not properly configured to handle power loss situations. Harmonic distortion can be generated, further complicating the power quality. The UPS is designed to provide a clean and stable power supply. It is sensitive to voltage and frequency fluctuations. Backfeed from motors can create these fluctuations, preventing the UPS from recognizing a true power outage and initiating the transfer to battery. The UPS may interpret the backed voltage as a partially restored power supply, preventing the switchover. The UPS internal protection mechanisms might also activate, shutting down the system to prevent damage from the irregular power input. The recommendation of an isolation transformer on the primary side of the UPS aims to address this issue by providing electrical isolation between the utility power and the UPS input. The transformer's primary winding is electrically isolated from its secondary winding, preventing the transfer of DC current or common mode noise from the utility side to the UPS. This isolation can block backed voltage from reaching the UPS, allowing it to detect the power outage and transfer to battery mode as intended. It is important to size the isolation transformer appropriately for the UPS. The transformer must be capable of handling the UPS full load current and any emerge current that occurs during startup. An undersized transformer can overheat and fail, negating any benefits it might provide. The isolation transformer should also have low impedance to minimize voltage drop and ensure that the UPS receives a stable voltage supply. The transformer should be installed as close as possible to the UPS to minimize voltage drop and noise pickup in the wiring. Proper grounding of the transformer is critical to ensure safety and proper operation. The transformer's enclosure should be grounded to the main grounding electrode system of the building. The secondary winding of the transformer should have a neutral ground bond established at the transformer location. The UPS manufacturer's specifications should be followed for grounding requirements. The effectiveness of the isolation transformer can be verified using a power quality analyzer. The analyzer can measure voltage, current, frequency, and harmonic distortion at the UPS input and output. It can also measure common mode noise and ground current. These measurements can be used to assess the impact of the isolation transformer on the power quality and the UPS operation. While the isolation transformer can help mitigate issues related to backfeed, it is crucial to address the underlying causes of the ground current. The isolation transformer does not solve the ground current problem, it only isolates the UPS from the effects of the ground current. The excessive ground current should be eliminated to prevent equipment damage and potential shock hazards. The unauthorized neutral ground bonds must be identified and disconnected. This requires a systematic approach to tracing the wiring and connections throughout the electrical system. Begin by disconnecting all loads and sources of power from the system. Use a multimeter or impedance tester to measure the resistance between neutral and ground at various points in the system. A lower resistance reading indicates a neutral ground bond. Trace the wiring from the point of low resistance to the location of the bond. Disconnect the bond and verify that the resistance between neutral and ground increases. Repeat this process until all unauthorized neutral ground bonds are identified and disconnected. Once the unauthorized neutral ground bonds have been eliminated, verify that the neutral and ground are bonded only at the main service entrance panel and at separately derived sources. Use a ground current tester to measure the current flowing on the ground conductor. The ground current should be minimal, typically less than 5 amps. If the ground current is still excessive, investigate other potential sources of ground current, such as faulty equipment or wiring insulation breakdown. It is important to ensure that all electrical equipment is properly grounded to the building's grounding electrode system. This includes the UPS, isolation transformer, distribution panels, and all connected loads. Proper grounding provides a low impedance path for fault current to flow back to the source, tripping circuit breakers and protecting equipment and personnel. All grounding connections should be clean and tight. Corrosion can increase the resistance of grounding connections, reducing their effectiveness. Grounding conductors should be sized according to applicable electrical codes. Small grounding conductors can overheat and fail under fault conditions. Regular maintenance of the electrical system is essential to prevent ground current problems and UPS transfer failures. Inspect the wiring and connections for any signs of damage or corrosion. Test the UPS battery and charger regularly. Clean electrical panels and equipment to remove dust and debris. Grounding connections are tight. Proper maintenance helps ensure the safety and reliability of the electrical system. When investigating electrical problems, it is essential to follow a systematic approach. Gather as much information as possible about the problem, including the symptoms, the history of the problem, and any recent changes to the electrical system. Use appropriate test equipment to measure voltage, current, resistance, and power quality. Analyze the data collected to identify potential causes of the problem. Develop a plan to test the potential causes and verify the solution. Document all findings and actions taken. A systematic approach helps ensure that problems are resolved efficiently and effectively. Consulting with other electricians, engineers, or the UPS manufacturer can provide valuable insights and ensure that the right solution is implemented. Electrical codes and standards provide guidelines for safe and proper electrical installations. Familiarize yourself with the applicable codes and standards and ensure that all electrical work complies with these requirements. Safety is paramount when working with electricity. To energize circuits before working on them. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Follow lockout/tagout procedures to prevent accidental energization of circuits. If you are not qualified to perform electrical work, hire a licensed electrician. In summary, the ground current issue requires meticulous identification and disconnection of any unintended neutral ground connections, along with verification that proper bonding exists solely at the service entrance and any separately derived sources. Addressing UPS transfer issues demands a thorough inspection of wiring, battery performance, and load characteristics, with potential solutions ranging from UPS upgrades to filtering measures, always in close collaboration with the manufacturer. A systematic approach, thorough data collection, and strict adherence to safety protocols are essential for effective troubleshooting and resolution of electrical problems.